Hey everyone, good morning, and I'm really looking forward to dividing into cybersecurity today and exploring how machine learning plays a crucial role in spotting network anomalies. I'm Mustafa, and I'm all about using tech to boost our online security. So, with our increasing dependence on the internet, the threats are also on the rise, right? So, the old school method of detecting anomalies, which depends on signature matching that we usually used in olden days, often become an outdated before even know to get to know about them, like to use them. So, this has to lead to more cyber incidents and a real need for smarter detection systems. So for that, I'm using the that's why the machine learning comes in a proactive and flexible solutions. Algorithms like SVM, random forest, and convolutional neural network CNN can learn from a data, spot unknown threats, and cut down the false positives. So it's a total game changer in the battle against cybercrime. So let's break down some of the machine learning techniques we have at our fingertips. SVM are the great classifiers that helps to find the best boundary between the different data points. Random forest combines several decision trees to enhance predictive accuracy and stability. CNN is originally for image recognitions are now being used to analyze network traffic thanks to their recognizing complex patterns. So the UNSW NB15 dataset is a treasure trove for cybersecurity researchers. It's built with the real-world network traffic data, showcasing both the harmless and harmful activities. So my project aimed to pre-process this data, implement the SVM, random forest, and CNN models, and thoroughly access their performance. So this has been in a related work, even though machine learning has shown potential for spotting anomalies, there are many studies that compare these techniques under the same conditions in real world network settings. So this lack of research is what motivates my study. So for methodology, we took a great care of pre-processing in UNSW NB15 dataset. We tackled the missing values and cat, uh, encoded some features and eliminated highly correlated features to avoid multicollinearity. So feature scaling was done to make sure every feature had an equal say in the learning process. So for the model training, I have a program run in my Google collaborations with the Jupyter Notebook, and using Python, I have trained these um we move on. We set up an SPM with a linear kernel for ease of use. Random forest were configured with 100 trees and the max depth of 10 to strike balance between the complexity and the predictive strength. For CNN, we included an convolutional layer and the max pooling layer to capture the detailed features in the data. So here and after I get into run this program, this is my SVM confusion matrix, and this is my random forest confusion matrix. Then after that, this is my CNN confusion matrix, and this is the CNN model accuracy. So yeah, now for and this is my evaluation. Our evaluation process was thorough. We used a metrics like precisions, recall, F1 score, and accuracy to evaluate the models. SVM hit about a 60 percentage. SVM hit about 60 percentage accuracy, while both random forest and CNN scored 82 percentage. So notably, CNN had a high recall for detecting anomalies. So these are the SVM class, SVM random forest and CNN percentage. And for the conclusion part, to wrap it up, actually, random forest and CNN outshone SVM in our research. The limitations of SVM were clear, especially with the linear kernel and imbalanced data. In contrast, random forest and CNN showed a strong capability to learn complex patterns and effectively identify the anomalies. So, for the future work, Mm, our future will efforts will focus on tackling the model complexity and overfitting, fine tuning hyperparameters, dividing into advanced feature engineering, addressing class imbalance, and optimizing computational resources. I am also looking into more evaluation metrics to ensure our models are both robust as well as reliable. So I appreciate your I may appreciate your giving me an opportunity to explain this machine learning and cybersecurity. I'm looking forward to hearing your insights and tackling many questions you might have. Let's keep these discussions going, collaborate to protect our digital world. And thank you.